What does A and Z stand for? Z stands for atomic number. And what is that? That is the number of protons in an atom. For example, let's take nitrogen. If you look in the periodic table, nitrogen's atomic number is 7. 7 atomic number means it has 7 protons. And since it's a neutral atom, then the number of electrons will also be 7. Now what does A stand for? A stands for atomic mass or mass number. And if again you look at in the periodic table, nitrogen atomic mass is 14. And what is atomic mass? It is the number of protons plus number of neutrons. That means number of protons plus number of neutrons are 14. Now since the number of protons are 7, then how many will be the neutrons? Neutrons will be 7. So how can you find out the number of neutrons? By mass number, the mass number minus atomic number gives you the number of neutrons. Now the mass of a single atom is very small and you cannot measure it in grams. So to express the mass of the unit of the atom, we use a different unit which we call it as atomic mass unit, AMU. So if we say what is the uh, mass of one atom of nitrogen, then it is 14 AMU. What is the mass of one atom of carbon? It is 12 AMU. We cannot say grams here. Now how do you define AMU? It is 1 AMU is defined as which is equal to exactly 1/12 of the mass of a carbon 12 atom. This is the way we define AMU. Um, the next topic is the isotopes. What are the isotopes? Isotopes are the atoms of the same element with the same number, same atomic number, but different atomic mass. For example, if you look at these three atoms of hydrogen, they all have the same atomic number. We write down the atomic number as a subscript on the left side. So they all have the same atomic number but different atomic mass. Again, how do you write down atomic mass? You write that down as a superscript on the left side. So again, these are the three atoms of hydrogen, same element, with the same atomic number but different atomic mass, and these are known as isotopes. So basically what is different? If 1 is the atomic number, that means each of these three atoms have, how many protons are there? 1, 1, 1. Electrons, 1, 1, 1. But how many neutrons? 1 how do you find neutrons? So the number of neutrons 0, 1 and 2. So basically isotopes are atoms of the same element with same atomic number but different atomic mass. Similarly, if you look at carbon, carbon has 6, 12, 6, 13, 6, 14. So these are the three isotopes of carbon with same atomic number but different atomic mass, or we can say with the same number of protons but different number of neutrons. Now in the periodic table you see carbon written only on one place. There are not, these three isotopes are not given the different position in the periodic table. So the carbon that we are writing in the periodic table, the mass of that is 12.01. Where is this number then coming from? So for that, what you need to understand that since the atoms exist in different isotopic forms, so what we do, we calculate the average atomic mass, but we can calculate this only if we know the mass of each and every isotope as well as the percent abundance of each isotope in the nature. How do we do that? So, for example, let's look at this problem. Here, naturally occurring silicon exists as three isotopes: silicon 28, silicon 29, silicon 30. So these are the three isotopes of, um, let me erase this and write down again. Um, Silicon 28, silicon 29, silicon 30. Now, silicon 28 with the mass of 27.97. So, in the next column, write down the mass of this silicon 27. Sorry, silicon 28. I don't know what's wrong with me today. Um, and the percent abundance, that in nature 92.23% is silicon 28. So convert this percent to the fraction. Percent means divide by 100. So it will be 0.9223. And again, how did I get this 0.9223? 92.23 divided by 100 to get rid of this percent sign. Silicon 29. So this is, what is this? This is the mass in AMU. This is the abundance. This one is abundance. Similarly, silicon 29, it's the mass is 28.977 and percent abundance is 4.67%, divided by 100, it is 0.0467. And silicon 30, the mass is, let me erase this so that you can see it clearly. Silicon 30, mass is 29.974, percent abundance is 3.10, divided by 100 will give you 0.0310. This is the abundance. This column is abundance. This number was 9223. Now the next column is where you write down average atomic mass, and again the unit is AMU. And what do, you multiply 27.977, you do this 20 times 0.9223, and when you multiply these two numbers you get 25.803. Again, 28.977 times 0.0467, it is 1.353. The last one, 29.974 times 0.0310, and that's equal to 0.929. And you add these three numbers, you get, when you add all these three numbers, you will get, your answer will come out, if you report in 4 sig figs, is going to be 28.09. And that's it, this is your answer.
Made with Doodlecast Pro.